Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Serverless computing represents a fundamental shift in how applications are built and deployed. Rather than renting or managing servers directly, developers focus solely on writing code and wiring together services. The infrastructure is completely managed by AWS, including provisioning, scaling, and maintenance. The "no servers to manage" phrase does not mean servers vanish. It means their existence is abstracted away, freeing teams from operational overhead. For learners, think of it like taking public transit instead of owning a car. The buses and trains still exist, but you don't fuel them, maintain them, or worry about breakdowns. You simply pay for each ride. In AWS, serverless follows the same model. You pay for actual use, while AWS keeps the engines running behind the scenes. 3 traits define serverless: automatic scaling, pay-per-use pricing, and managed operations. Applications scale instantly as load increases, shrinking back down when idle. You are billed based on consumption, measured in requests, execution time, or data processed, rather than paying for idle capacity. Operations such as patching, monitoring, or capacity planning are handled by AWS. Beginners should picture an electricity grid. You turn on a light, consume power, and pay for the usage without worrying about power plants or maintenance. This model provides agility for developers while optimizing cost and scale. The centerpiece of serverless in AWS is AWS Lambda, a functions-as-a-service platform. With Lambda, you upload code in supported languages, and AWS executes it in response to events. These events can come from API requests, file uploads, database updates, or scheduled timers. Lambda automatically provisions runtime environments, executes the code, and tears them down when complete. Beginners should think of Lambda as a just-in-time chef. They prepare meals only when customers order, and once the meal is served, they leave the kitchen. This model ensures zero idle cost and elastic execution capacity. Serverless computing is not just about functions. It includes back-end services like S3 for object storage, DynamoDB for NoSQL databases, and Cognito for identity management. These services scale without administrators managing servers, patching operating systems, or monitoring hardware. Beginners should see these as cloud utilities. S3 acts like a limitless filing cabinet, DynamoDB like a high-speed digital ledger, and Cognito like a doorman verifying identities. Together, they form the data and identity layers of serverless architectures. Integration services are critical to wiring serverless systems together. API Gateway enables developers to expose APIs without managing web servers. Event Bridge routes and transforms events between applications. Step functions orchestrate workflows, chaining functions and services into cohesive processes. For learners, picture a relay race. API Gateway takes the baton from the outside world. Event Bridge directs traffic between runners, and Step Functions ensures everyone runs in the correct order. Without these services, serverless functions would remain isolated. With them, they form powerful, event-driven architectures. Messaging services complement serverless computing by enabling decoupled asynchronous communication. Simple Notification Service (SNS) supports a publish/subscribe model, where one message fans out to multiple subscribers. Simple Queue Service (SQS) provides durable queues for tasks to be processed by workers. Beginners should imagine SNS as a town crier shouting news to a crowd, while SQS is like a line at the post office where each customer is served in turn. These tools keep systems flexible, fault-tolerant, and scalable. At its heart, serverless thrives on event-driven design. Events from user actions, file uploads, or system alerts trigger responses in real time. This decoupling allows systems to evolve into smaller, modular pieces that interact without tight dependencies. Beginners should see this as a factory with conveyor belts. Parts move automatically from station to station, and each station does its work independently. If one breaks, the belt keeps moving, and workers downstream continue. Serverless architectures mirror this, increasing agility and resilience. Serverless also aligns naturally with microservices. Each function or service handles a small, well-defined responsibility, allowing teams to develop, test, and deploy independently. This agility reduces time to market and simplifies scaling. Beginners should compare this to a food court. Each vendor specializes in one cuisine, scales its kitchen independently, and adjusts its menu without impacting neighbors. Microservices combined with serverless empower teams to move quickly while minimizing risk. The benefits of serverless are clear: speed of delivery, automatic scalability, and cost efficiency. Developers focus on business logic rather than provisioning servers. Capacity matches demand automatically, preventing over or under provisioning. Billing aligns directly with usage, reducing waste. Beginners should think of it as switching from owning a large van just in case to using ride-sharing. You only pay when you ride, and someone else manages the vehicle. This model encourages experimentation, rapid iteration, and leaner operations. Yet serverless comes with challenges. Cold starts occur when a Lambda function hasn't been invoked recently, causing a small delay while AWS initializes the runtime. Hard limits exist for execution time, memory, and package size. Packaging code and dependencies may require build pipelines, especially in larger applications. Beginners should picture this as ordering a meal from a chef who hasn't entered the kitchen yet. You wait longer while they prep. These issues are manageable, but they highlight that serverless is not a magic wand. Another limitation is statelessness. Lambda functions and similar services cannot store session state internally because their execution environments are temporary. State must be externalized into services like DynamoDB, S3, or RDS. Beginners should imagine using a shared locker system. Workers can't keep belongings at their desk, but they can store them in lockers accessible across shifts. This externalization enables scalability, but it requires new design habits compared to traditional servers. Security in serverless relies heavily on IAM roles and policies. Each Lambda function, API gateway endpoint, or step function runs with specific permissions, defining what it can access. Misconfigurations can grant excessive privileges or block essential access. Beginners should think of this as giving keys to workers. Too many keys expose you to theft. Too few prevent them from doing their jobs. Least privilege remains a golden rule, and AWS enforces it through fine-grained role assignments. Observability must also adapt in serverless environments. Traditional monitoring of CPU and disk is irrelevant when you don't manage servers. Instead, tools like CloudWatch Logs, CloudWatch Metrics, and AWS X-Ray provide visibility into execution times, errors, and event flows. Beginners should imagine air traffic control. The controllers don't care about the make of each plane, only its path, altitude, and timing. In serverless, the focus shifts to request latency, success rates, and tracing flows across distributed services. Serverless computing supports diverse use cases across industries. E-commerce companies process orders with Lambda and SQS. Media platforms transcode video on demand with Lambda triggered from S3 uploads. Healthcare providers build secure APIs with API Gateway and DynamoDB. Even financial services leverage step functions for compliance workflows. Beginners should see serverless as a flexible toolkit. It can build chatbots, IoT pipelines, fraud detection, or simple websites. The diversity of examples shows its broad utility, limited only by imagination and fit for workload patterns. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. One of the most common serverless patterns is building APIs with API Gateway and Lambda. API Gateway handles incoming HTTP requests, while Lambda functions execute the business logic and return responses. This pairing allows developers to build entire web applications without provisioning servers. For example, a to-do list application might expose endpoints like /create task or /list tasks, each backed by a Lambda. Beginners should see this as a receptionist taking orders and handing them to on-demand workers who complete tasks instantly. The combination delivers scalability, flexibility, and cost efficiency, especially for lightweight, stateless applications. Serverless also excels at stream processing. Data from services like Kinesis or Amazon Managed Streaming for Apache Kafka (MSK) can flow directly into Lambda functions for real-time analysis. This enables scenarios like monitoring social media sentiment, processing IoT sensor data, or detecting fraud in transaction streams. Beginners should imagine a conveyor belt carrying items past inspectors who check and sort each one. The stream never stops, and inspectors, Lambda functions, scale automatically with the volume of items. This design makes serverless ideal for continuous, high-velocity data flows. Orchestration is another strength, handled by AWS step functions. Instead of embedding workflow logic into code, step functions manage the sequence, branching, and error handling across multiple functions or services. For example, processing a loan application might involve steps for identity checks, credit scoring, and approvals, each coordinated by a state machine. Beginners should see step functions as a stage director who ensures every actor enters on cue, speaks their lines, and exits on time. This orchestration simplifies complex workflows while improving reliability and maintainability. Lambda supports both synchronous and asynchronous invocation models. A synchronous call waits for the function to complete and return results, as in an API request. An asynchronous call queues the event, returning immediately, and retries if the function fails. Each model fits different needs: synchronous for real-time user interaction, asynchronous for background jobs. Beginners should think of this like a phone call versus sending an email. A call demands immediate attention, while an email lets the recipient respond when ready. Recognizing the right model ensures responsiveness without overloading systems. Dead letter queues, DLQs, and ID impedency are key patterns for reliability. If a Lambda fails repeatedly, its events can be routed to SQS or SNS for later review. Idempotency ensures that retrying an event doesn't duplicate work, such as charging a customer twice. Beginners should picture this as having a returns desk for failed orders and a safeguard that prevents duplicate receipts from being printed. These patterns ensure serverless architectures are not only scalable, but also robust against transient failures. Accessing VPC resources securely is another consideration. By default, Lambda functions run in an AWS-managed VPC. To reach private resources like RDS databases, they can be configured to attach to a customer VPC with appropriate subnets and security groups. Beginners should imagine moving from a public co-working space into a company's private office. You gain access to sensitive files, but must pass through stricter security. This design balances convenience with secure access, ensuring Lambda integrates smoothly into enterprise architectures. Data persistence choices often involve DynamoDB versus RDS. DynamoDB, a fully managed NoSQL service, is ideal for scalable, low-latency workloads, while RDS provides traditional relational databases with SQL features. Beginners should think of DynamoDB as a fast digital ledger that grows effortlessly, while RDS is like a structured library where every book is cataloged and relationships between them matter. Choosing between the two depends on whether the workload prioritizes flexibility and scale or relational consistency and complex queries. File workflows frequently rely on S3 events triggering Lambda functions. Uploading an image to S3 can trigger a Lambda to generate thumbnails, transcode video, or scan for malware. This decoupled pipeline means storage and processing remain loosely connected yet seamless. Beginners should think of this as dropping clothes into a laundry chute that automatically alerts staff to wash and fold them. The workflow is event-driven, scalable, and requires no ongoing management of servers. Concurrency and throttling are critical topics in serverless. AWS limits the number of functions that can run simultaneously to protect accounts from runaway costs or abuse. Exceeding concurrency limits results in throttled requests, which may queue or fail depending on configuration. Beginners should picture a theater with a finite number of seats. Once full, new guests must wait outside or be turned away. Designing with these limits in mind ensures workloads handle traffic surges gracefully without overwhelming resources. Cost modeling in serverless is distinct from EC2. Lambda charges are based on requests and execution duration measured in milliseconds, along with memory size allocated. Other services, like API Gateway or SQS, charge per request or message. Beginners should think of this like paying for utilities. A water bill is based on gallons used, not ownership of the pipes. While usually cost-efficient, poorly written or long-running functions can become unexpectedly expensive, so optimization matters. Serverless is not a universal solution. It struggles with long-running tasks, exceeding time limits, highly stateful workloads, or cases requiring specialized hardware like GPUs. Beginners should compare it to ride-sharing, perfect for short trips, but impractical for a cross-country move where a dedicated vehicle makes more sense. Recognizing these boundaries ensures teams deploy serverless in contexts where its strengths shine, while leaning on EC2, ECS, or EKS for workloads outside its sweet spot. Security and compliance remain shared responsibilities in serverless. While AWS patches and maintains the infrastructure, customers must enforce least privilege IAM roles, encrypt sensitive data, and monitor event flows for anomalies. Beginners should think of this as a secured building, where the landlord provides guards and locks, but tenants must still safeguard their own valuables. Serverless reduces operational burden, but does not absolve teams of securing application logic, data, and permissions. From an exam perspective, learners should focus on mapping requirements to the correct serverless service. If the scenario describes file uploads triggering workflows, S3 and Lambda are the answer. If it highlights APIs without servers, API Gateway plus Lambda is implied. Messaging patterns map to SQS or SNS, orchestration points to step functions, and high-velocity streams to Kinesis. Recognizing these mappings ensures exam success and, more importantly, sharpens the ability to design event-driven systems in practice. In conclusion, serverless computing is about speed, efficiency, and event-driven design. It empowers teams to move faster by removing infrastructure friction, automatically scaling with demand, and aligning costs with actual usage. For learners, the lesson is clear. Serverless is not magic but a set of finely tuned building blocks. Used appropriately, it accelerates innovation, supports agility, and creates resilient architectures. When requirements demand rapid delivery and fine-grained event-driven systems, serverless is the natural fit in AWS. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.